A massive object, far larger than Oumuamua, has just entered our solar system at interstellar speeds. It's not a comet, not an asteroid, and scientists have no idea what it truly is. Could this be something entirely new? On the night of July 1st, 2025, astronomers using the Atlas telescope in Chile spotted something unusual, a tiny moving that just passed the orbit of Jupiter. At first, it seemed like a routine observation, just another asteroid or comet making its way through the solar system. But within hours, scientists realized they were witnessing something extraordinary, a comet not from our solar system, but from the vast space between the stars. Now named Comet 3I/Atlas, this icy traveler is only the third interstellar object ever discovered. And just days after its detection, it has already become a global astronomical sensation. This new interstellar object could solve the mysteries left behind by its two predecessors, Oumuamua and Comet Borisov. But how do we know that 3I/Atlas is an interstellar object? The key to identifying an object as interstellar lies in its motion. Most comets, asteroids, and planets in our solar system orbit the sun in elliptical paths, their speed balanced by the pull of the sun's gravity. But 3I/Atlas is moving too fast, about 70 kilometers per second relative to the sun. That's far above the escape velocity of the solar system at its location. An object traveling at such speed can't be gravitationally bound. It's just passing through. This trajectory is best described as hyperbolic, and its shape is mathematically defined by orbital eccentricity. A circular orbit has an eccentricity of 0, an ellipse falls between 0 and 1, and a parabolic escape trajectory is exactly 1. Anything above 1 is hyperbolic, and 3I/Atlas currently has an eccentricity estimated above 6, a strong sign that it is indeed interstellar in origin. The next question is that how do we know it's a comet? Classifying 3I/Atlas as a comet means it's not just a dry rock hurtling through space. It's an icy body that reacts visibly to the heat of the sun. As sunlight warms the surface, volatile ices begin to sublimate, releasing gas and dust that form a coma and sometimes a tail. Initial observations of 3I/Atlas suggested a faint fuzziness around the object. This halo indicated the start of cometary activity. Over 100 follow-up observations from around the world soon confirmed tentative signs of a coma and a short tail. These are the hallmarks of a comet beginning to shed material as it nears the sun. The International Astronomical Union quickly updated its classification to C/2025N1, recognizing its active, icy nature. The name follows a standardized naming convention used by the International Astronomical Union for newly discovered comets, and each part of the name reveals something important about the object. The prefix C/ indicates that the object is a non-periodic comet, meaning it is not expected to return on a predictable orbit. 2025 denotes the year in which the comet was discovered. Finally, we have a letter number combination N1. This part is broken down into two components. N refers to the half-month in which the object was discovered. The IU divides each year into 24 half-month intervals, with A representing the first half of January, B the second half, and so on. N corresponds to the first half of July since the letter I is omitted to avoid confusion with 1. This means it's the first non-periodic comet discovered in the first half of July 2025. The object's brightness also supports its cometary nature. While brightness alone doesn't confirm a comet size because ejected dust reflects light, it does suggest activity. Currently, estimates place its size anywhere from 5 to 50 kilometers in diameter, potentially making it the largest interstellar object ever observed. At the time of its discovery, 3I/Atlas was about 670 million kilometers from Earth and had entered the orbit of Jupiter. It's about 2.5 million times fainter than the pole star. Comet 3I/Atlas is expected to reach its perihelion, its closest point to the Sun, around October 30th, at a distance of about 206 million kilometers or just inside Mars' orbit. However, during this time, it will be on the opposite side of the Sun from Earth, limiting direct observation. By early December, 3I/Atlas will reappear from behind the Sun, providing another window for observation before it dims and recedes into the distance. It will likely remain visible to large telescopes until early 2026, after which it will fade into the darkness of interstellar space once again. Before 3I/Atlas, only two interstellar objects had ever been confirmed, both of them radically different from each other. The first was Oumuamua, discovered in October 2017. Its trajectory was unmistakably interstellar, but what truly puzzled scientists was its strange behavior after passing the Sun. Unlike most space rocks, Oumuamua didn't just follow a gravitational path. It experienced a slight, but measurable, acceleration, as if something was gently pushing it away from the Sun. This kind of non-gravitational acceleration is usually caused by outgassing, jets of vapor that erupt from the surface of a comet as it heats up. But there was a problem. Oumuamua showed no signs of a coma or tail, the usual evidence of sublimating ices. Adding to the mystery, the way its brightness changed over time suggested it was spinning and shaped in an extreme way, highly elongated like a cigar or flat like a pancake, something we've never seen in a natural object before. These strange characteristics sparked several theories. Some scientists suggested that exotic ices, like hydrogen or nitrogen, might have vaporized without leaving visible traces. Others, more provocatively, speculated that it could be an artificial object, perhaps a light sail from an alien civilization. The idea of an artificial alien object captured headlines, but has since been largely ruled out by the scientific community. Today, most researchers agree that Oumuamua was a natural object, although its exact composition and origin remain open questions. Then came 2I/Borisov in 2019. Discovered by an amateur astronomer, it looked and acted exactly like a regular comet, complete with a bright coma, a long tail, and carbon-based ices. It was a relief in some ways, confirming long-held expectations about what an interstellar comet should be. It also proved that our solar system isn't unique in producing icy bodies capable of surviving interstellar travel. Together, Oumuamua and Borisov revealed that interstellar objects can be wildly diverse, some rocky and mysterious, others icy and familiar. And now, 3I/Atlas offers a third data point, crucial for understanding which of these objects is the norm and which is the outlier. 3I/Atlas arrives at a perfect time. With improved global survey capabilities, astronomers are better prepared than ever to study this fleeting visitor. And it could help answer the lingering questions raised by Oumuamua. First, its cometary nature, with actual signs of a coma and tail, contrasts directly with the inactivity of Oumuamua. If 3I/Atlas behaves like a typical comet from another star, it would suggest that Oumuamua was the odd one out, possibly a fragment of a larger body or shaped by extreme space weathering. On the other hand, if 3I/Atlas begins to show strange behavior as it nears the Sun, such as unexplainable acceleration or unusual chemical signatures, it might hint that Oumuamua wasn't so strange after all. Further, by comparing the chemical composition of 3I/Atlas with both Borisov and local comets, scientists can test whether planetary systems throughout the galaxy form similar ices and organics, or if each system is chemically unique. This kind of research offers direct insight into planet formation around other stars. Comet 3I/Atlas may be only the third interstellar object ever detected, but thanks to a revolutionary new telescope, it may soon be one of many. Central to the future of interstellar object discovery is the Vera C. Rubin Observatory, currently being completed in Chile. Rubin is unlike any telescope that has come before. Its massive 3.2 gigapixel camera and wide field of view will allow it to survey the entire night sky every few days. That means it can catch transient, fast-moving objects like interstellar visitors sooner and more frequently than traditional observatories. As announced at the First Look event, Rubin has already discovered over 2,100 new asteroids within just hours of observations. When it becomes fully operational, it's expected to dramatically increase the discovery rate of asteroids, comets, and interstellar objects. Instead of waiting years between finds, scientists hope to spot multiple interstellar visitors every decade, or even every year. This increased sample size is key. Currently, with only 3 known ISOs, astronomers are working with a tiny statistical dataset. However, with more examples, They'll be able to categorize ISOs by type, trace their likely origins, and build a more comprehensive understanding of how planets and comets form and how they are ejected into space. As 3I/Atlas races through our skies over the coming months, astronomers will be watching it closely, hoping to unlock more of these cosmic secrets. And thanks to better tools, more powerful telescopes, and upcoming missions, we are better equipped than ever to catch the next visitor from the stars. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.